just completed Chapter 7, which was sanitary waste systems. We're going to jump right into indirect waste next. So you can start to see, once we get to Chapter 7, a sequence of order based on types of drainage. And the next more logical would be Chapter 8, which would be the indirect waste. And then Chapter 9, which would be vents, and then Chapter 10, which is traps and interceptors. So those 4 chapters, they coincide with each other, but they're split. So we're going to specifically talk about indirect wastes tonight. And we're going to start with section 801.2, air gap or air break required. Indirect waste piping shall discharge into the building drainage system through an air gap or air break as set forth in this code. Where a drainage air gap is required by this code, the minimum vertical distance as measured from the lowest point of the indirect waste pipe or the fixture outlet to the flood level rim of the receptor shall be not less than 1 inch. And in the receptor is actually the floor sink in most cases. So that's what we're going to be working on. Hang on, I'm going to focus here for a sec. So much better, so much better. Okay. So the minimum air gap is 1 inch, okay, above the receptor. This is where the outlets needs to end. Food and beverage handling establishments. Establishments engaged in the storage, preparation, selling, serving, processing, or other handling of food and beverage involving the following equipment that requires drainage shall provide indirect waste piping for the refrigerators, refrigeration coils, freezers, walk-in coolers, ice boxes, ice-making machines, steam tables, egg boilers, coffee urns and brewers, hot and cold drink dispensers, and similar equipment. Size of your indirect waste pipe. Except for refrigeration coils and ice-making machines, the size of the indirect waste pipe shall be not smaller than the drain on the unit, but shall be not smaller than 1 inch, and the maximum developed length shall not exceed 15 feet. Indirect waste pipe for ice-making machines shall be not less than the drain on the unit, and in no case less than 3/4 of an inch. So everything needs to be not smaller than 1 inch except the ice-making machines. Those can be a 3/4 inch drain. Walk-in coolers. For walk-in coolers, floor drains shall be permitted to be connected to a separate drain line discharging into an outside receptor. The flood level rim of the receptor shall be not less than 6 inches lower than the lowest floor drain. Such floor drains shall be trapped and individually vented. Cleanouts shall be provided at 90-degree turns and shall be accessibly located. Such waste shall discharge through an air gap or air break into a trapped and vented receptor, except that a full-size air gap is required where the indirect waste pipe is under vacuum. So, what they're talking about here is a walk-in cooler. So let's break out the old pen and paper. Now let's see here. So you have a walk-in cooler. So here's this cooler, right? And it's a walk-in. All right. So yeah, I know it looks like a house, but anyways, it's a cooler. Okay. Now, the cooler is going to be used for storing food and everything else. Let's say that we have some kind of a condensate that needs to run out of this, and let's say it dumps into a floor drain or something, or maybe there's even just a drainage for the floor drain. So we have a floor drain in here. Well, this floor drain, everything dumps out, runs out. You can take it to a receptor. So let's put a floor drain, or floor sink, excuse me, right here, and that goes over to a wall, and that gets vented, you know, accordingly, right? So this is our floor sink here. I can take this and run it all the way over to here and dump it in there, okay? This is my trapped drain. This, as long as it's no longer than 15 feet, I can go ahead and drop it in as an air gap. And this receptor needs to be 6 inches lower than the floor drain, than the lowest floor drain. That's what that code section talks about. And I hope that makes sense, because I love drawing my little chicken scratch, right? Food handling fixtures. Food prep sinks, steam kettles, potato peelers, ice cream dipper wells, and similar equipment shall be indirectly connected to the drainage system by means of an air gap. The bins, sinks, and other equipment having drainage connections and used for storage of unpackaged ice, used for human ingestion, or used in direct contact with ready-to-eat food shall be directly connected to the drainage system by means of an air gap. And each indirect waste pipe from a food handling fixture or equipment shall be separately piped to the indirect waste receptor and shall not combine with any other indirect waste pipe. Before we continue on with the next question, I want to make sure that you understand most of what this whole chapter is about. Human ingestion, okay? It's all based on anything with human ingestion, designed for human ingestion. You can't connect it directly to a drainage system. You have to do it indirectly to the drainage system by means of an air gap. That's what's key. That's what you have to do. Okay? And then the next one is the piping from the equipment to the receptor shall be not less than the drain on the unit, and in no case less than ½ inch. Bar and fountain sink traps. So where the sink in a bar, soda fountain, or counter is so located that the trap serving the sink can't be vented, the sink drain shall discharge through an air gap or an air break into an approved receptor that is vented. The developed length from the fixture outlet to the receptor shall not exceed 5 feet. Now this is the one for the bar sink. So now you can't exceed 15 feet inside a walk-in cooler, and you can't exceed 5 feet for a bar sink. Okay? Okay, connections from water distribution systems. Indirect waste connections shall be provided for drains, overflows, or relief pipes from a potable water pressure tank, water heater, boiler, or similar equipment that is connected to the potable water distribution system. Such indirect waste connections shall be made using a water distribution air gap constructed in accordance with Table 603.3.1. And we'll get to that. Actually, we already did. We talked about that one. If you don't recall, go back to the Chapter 6 lecture, and we talked specifically about Table 603.3.1. Sterilizers. Excuse me. Okay, sterilizers. Lines, devices, or apparatus such as a still sterilizer and similar equipment requiring waste connections and used for sterile materials shall be indirectly connected using an air gap. Each such indirect waste pipe shall be separately piped to the receptor and shall not exceed 15 feet. So here we are back with the sterilizer having a 15-foot indirect waste pipe. Such receptors shall be located in the same room. Now, a sterilizer is like in a lab or somewhere where they need to sterilize their glass beakers and stuff like that. You would use something that would just superheat it and drain it out. And again, it's almost like a dishwasher, and we'll talk about that too. Drip or drainage outlets. Appliances, devices, or apparatus not regularly classified as a plumbing fixture, but which have a drip or drainage outlet, shall be permitted to be drained by indirect waste pipe discharging into an open receptor through either an air gap or an air break. Section 802. No plumbing fixture served by indirect waste pipe or receiving discharge therefrom shall be installed until first approved by the authority having jurisdiction. But that goes back into Chapter 1 when you had to sit there and get permits for doing any kind of an install, right? Okay, section 803.0, indirect waste piping. The materials, pipe, tube, fittings conveying indirect waste shall be of such material and design as to perform their intended function to the satisfaction of the authority. Copper, you can use copper. Pipe size and length. Except as hereinafter provided, the size of an indirect waste piping shall be in accordance with other sections of this code applicable to drainage and vent piping. No vent from an indirect waste pipe shall combine with a sewer-connected vent, but shall extend separately to the outside air. Indirect waste pipes exceeding 5 feet, but less than 15 feet, shall be directly trapped, but such traps need not be vented. So if you exceed 5 feet, you got to trap it, okay? And you don't have to vent it, okay? And also, really quick, if you are venting any type of a system that is indirect waste, that indirect waste vent, if you are venting it, has to go separate, because the whole point is to not have any type of contamination with the two separate systems. Okay, you're not going to sit there and hook up an indirect waste vent into a direct vent system, because then if that sewer backs up and you have a positive pressure, or maybe there's a vent clog in the regular venting system, and that's going to backfeed into the vent system of the indirect, you're contaminating the foods through that indirect drain. Indirect waste pipes less than 15 feet in length shall be not less than the diameter of the drain outlet or tailpiece of the fixture, appliance, or equipment served, and in no case less than ½ inch. Angles and changes of direction in such indirect waste pipes shall be provided with a cleanout to permit flushing and cleaning. Section 804. This whole section is specific, sorry, pardon the shadow there, is specific to clothes washers. So let's read this and then we'll discuss. Plumbing fixtures or other receptors receiving the discharge of an indirect waste pipe shall be approved for the use proposed, and shall be of such shape and capacity as to prevent splashing or flooding, and shall be located where they are readily accessible for inspection and cleaning. No standpipe receptor for a clothes washer shall extend more than 30 inches, or not less than 18 inches above its trap. No trap for a clothes washer standpipe receptor shall be installed below the floor, but shall be roughed in not less than 6 inches and not more than 18 inches above the floor. No indirect waste receptor shall be installed in a toilet room, closet, cupboard, or storeroom, or in a portion of a building not in general use by the occupants thereof, except standpipes for clothes washers shall be permitted to be installed in a toilet in a bathroom area where the clothes washer is installed in the same room. So here we have a set of rules for your clothes washer. Okay, and they're talking about the clothes washer receptor, the standpipe receptor, the box that sits inside the wall. Okay, so you have a box, clothes washer box, right? So here's your box. And then your hose goes in, right? Goes up and in. Right? Okay, so here's your hose from the washer, and it dumps into here. Now you've got a receptor, standpipe. So there's my standpipe. And then you got your trap. Right? So this guy goes like that. The distance here of my standpipe is 18 to 30 inches. Okay? The trap, which is, there's always some argument as to where to measure your trap, but to me, the trap, the lowest point is here at the top dip. So we are going to go from the top dip to the ground, 6 inches to 18 inches. Okay? So that's our deal. So minimum that this washer box can sit above the floor, you got 18 and you got 6. So minimum 24 inches. Maximum 18 and 30. 18 and 30 is what? 48. So this guy right here at this distance is either going to be at minimum, great, 24 to 48 inches. Okay? So that's your washer box. Okay? So that's all of this stuff that's inside here. Probably something that might be on either a quiz or a test that might be coming up. You know, we'll see. But I'd give it about a 99.999% chance that you may want to know that. Section 805, pressure drainage connections. Indirect waste connections shall be provided for drains, overflows, or relief vents from the water supply system, and no piping or equipment carrying waste or producing waste or other discharge under pressure shall be directly connected to a part of the drainage system. The preceding shall not apply to an approved sump pump or to an approved pressure wasting plumbing fixture or device where the authority has been satisfied that the drainage system is adequately sized to accommodate the anticipated discharge. Sterile equipment. I know it's sterile, but sterile equipment. Appliances, devices, or apparatus such as a still, sterilizer, and similar equipment requiring water and waste and used for sterile materials shall be drained through an air gap. And again, we just talked about sterilizers back a couple of code sections ago, but they brought it up again to re-emphasize you do not want anything back feeding in. You don't want sewage coming back into something that's supposed to be sterile. Okay. Appliances, non-classed apparatus. A commercial dishwashing machine, silverware washing machines, other appliances, devices, equipment, or other apparatus not regularly classed as a plumbing fixture, which are equipped with pumps, drips, and drainage outlets, shall be permitted to be drained by indirect waste, discharging into an approved type of open receptor. It just makes sense. You're not going to sit there and pump that straight into hard pipe it into a waste system. You just don't. You dump it into a separate receptor, which is separately vented, and that receptor ties directly in, okay? Undiluted condensate waste. Where undiluted condensate waste from a fuel-burning condensing appliance is discharged into the drainage system, the material in the drainage system shall be cast iron, galvanized iron, plastic, or other materials approved for this use. Because undiluted condensate waste from a fuel-burning condensing appliance, so you can look at a high-efficiency water heater or a high-efficiency furnace. As it creates the heat necessary, the exhaust is such a high efficiency that it creates its own condensate. And that condensate is caustic. So you need to make sure that the material inside that drainage system is approved for use within the confines of that diluted condensate waste. Exceptions. Where the above condensate is discharged to an exposed fixture tailpiece and trap, such tailpiece and trap shall be permitted to be a copper alloy because it's exposed and you can take a look at it and replace it if you have to, you know. And then materials approved in section 701 shall be permitted to be used where data is provided that the condensate waste is adequately diluted. So you're looking at adequate dilution as opposed to the code section which starts off as undiluted condensate waste. But if you dilute it, it kind of gets rid of that concentrate of acidity, because that's pretty much what it is. It's an acidic condensate. Domestic dishwashing machine. Guess what we're going to do right here? We're going to do something called highlight. And we're going to highlight this because I love this code section, and I think you will too. No domestic dishwashing machine shall be directly connected to a drainage system or food waste disposer without the use of an approved dishwasher air gap fitting on the discharge side of the dishwashing machine. No matter what you say, this code section tells you that you shall not be directly connected to a drainage system unless you have a dishwasher air gap hooked up like you're supposed to. The listed air gap shall be installed with a flood level marking at or above the flood level of the sink or drain board, whichever is higher. That is an argument that consistently comes up. It's like, well, we don't want to drill another hole in the countertop of the kitchen next to the sink. We don't want to sit there and utilize one of the other holes in the stainless steel sink. We'd rather put in like some soap dispenser or something. No, you need this air gap. It has to go in. It has to be installed. Even if the manufacturer sits there and says you don't have to, the manufacturer is wrong. Because again, we'll go all the way back to chapter 1, and we will sit there and tell let me give you an instance. I have a coworker. He went to a customer's house. She happened to be a lawyer. And I'm not sure if I brought this up in chapter 1 video or not, but she was a lawyer and she got this nice concrete countertop. And she asked him, do I have to put in this air gap? He calls me up, says, hey, she doesn't want to put an air gap in because this is a really nice concrete countertop. She doesn't want to drill through it. What's the deal? And I said, no, we have to. It's code. You have to do it. So he told her that. He said, this is a code compliance issue, ma'am, and it needs to be done. And so she paid somebody to drill a hole through the concrete instead of us because she didn't want us to do it. But the dishwasher guy comes out to hook it up because she didn't want to pay us to hook it up. And the dishwasher guy said, no, you don't need an air gap. You just run the hose. Well, here's a dishwasher appliance delivery guy hooking this thing up, saying all you got to do is run the hose, run it up as high as you possibly can underneath the counter, and then tie it in. Well, guess what? That's illegal. You can't do that because if there ever is a sewage backup. Now think about this, okay? As a matter of fact, here, let's just draw this up because I love to draw. This guy, this so-called, wannabe plumber. So you have a sink, right? And there's a flood level rim. Okay? And we're going to do this and we're going to hook it up and we'll just do it like this, all right? There's no garbage disposal or anything like that. We're just going to hook it just like this. So they put in a Y branch tailpiece right here and they're going to hook this hose up. So at this point right here, they run a hose. And what they do is they run the hose as high as they can and then hook it in to your dishwasher over here. If there's ever a sewage backup, where's the sewage going to go? It's going to come through this trap, it's going to come up through here, and it's going to want to go all the way up to the sink and overflow out onto over the what's this called right here? The flood level rim, right? Well, there's no air gap here. So this is going to come up, raw sewage is going to come all the way back into here, and it's going to come into this dishwasher. And that's really gross, okay? But then the manufacturer's argument is going to be, well, we have an internal check right here, and it's going to be fine. Well, guess what happens if this dishwasher runs, and, most people don't sit there and clean out their internal check. What if some kind of a grindage deal or material got in here and kind of forced that little internal check open? Now you've got this dishwasher which loves to superheat, right? You open that thing up in the middle of a cycle, it's freaking hot, right? Well, nothing beats the smell of superheated sewage. And you're doing your dishes and you're cleaning this thing up and there's a sewage backup. Well, guess what's going to happen? You're going to get raw sewage in here and your dishes are going to smell like shit. So, to alleviate that, you go ahead and you put in an air gap. So now This comes up, comes down, ties in. This isn't here, right? Now, if there is a sewage backup, it's going to hit this point here and it's going to overflow and it's going to spill out. And it's not going to go in here. This is the reason. That's why you put it in. And I'm telling you, if you get into service and repair and somebody needs one and they say they don't, bring it up and say, well, this is why we use it and this is the purpose. Okay, we're putting it in to make sure that your dishwasher never receives raw sewage and your dishes never do that to a point. Can you imagine putting like all your Tupperware or something in there? It's plastic, man. It's porous. If you use Tupperware with like leftover lasagna, you'll never get that leftover lasagna out of that Tupperware. It's not going to be clear anymore. It's going to be nasty tomato paste looking, you know? So can you imagine what that is going to look like if it's raw sewage? Please. Sorry, get off my high horse on that code section. Talked about this for a little bit, so maybe it might be on a test. I don't know. Cooling water. Where permitted by the authority having jurisdiction, clean running water used exclusively as a cooling medium in an appliance, device, or apparatus shall be permitted to discharge into the drainage system through the inlet side of a fixture trap in the event that a suitable fixture is not available to receive such discharge. Such trap connection shall be by means of a pipe connected to the inlet side of an approved fixture trap, the upper end terminating in a funnel-shaped receptacle set adjacent and not less than 6 inches above the overflow rim of the fixture. Drinking fountains. Drinking fountains shall be permitted to be installed with indirect waste. It's because it's such a small amount of drainage that you can actually, it's no big deal. Steam, hot water drainage condensers, and sumps. No steam pipe shall be directly connected to plumbing or drainage, nor shall water having a temperature above 140 degrees be discharged under pressure directly into a drainage system. degrees. So the reason for that is if it's ever hotter than that, you're probably going to damage some of the piping. So they want to make sure you don't. Pipes from the boiler shall discharge by means of indirect waste piping as determined by the authority having jurisdiction of the boiler manufacturer's recommendations. Such pipes shall be permitted to be indirectly connected by discharging into an open or closed condenser or an intersecting sump of an approved type that will prevent the entrance of steam or such water under pressure into the drainage system. Closed condensers or sumps shall be provided with a vent that shall be taken off the top and extended separately full size above the roof. The condenser in the sump shall be properly trapped at the outlet with a deep seal trap extending to within 6 inches of the bottom of the tank. The top of the deep seal trap shall have a 3/4 inch opening located at the highest point of the trap to serve as a siphon breaker. Okay. Outlets shall be taken off from the side in such a manner as to allow a water line to be maintained that will permanently occupy not less than 1/2 the capacity of the condenser or sump. The inlet shall enter above the water line, and wearing plates or baffles shall be installed in the tank to protect the shell. The size of the blow-off line, inlet, the water outlets, and the vent shall be as shown in Table 810.1. The contents of the condensing receiving steam or hot water under pressure shall pass through an open sump before entering the drainage system. So then you have your pipe connection and a blow-off. So essentially what they're saying is if you've got a bunch of water that's over 140 degrees, you're going to dump that thing into a pit and it's going to cool itself off to where it's below 140 degrees before it goes into the drainage system. So it's just like this giant pit, and it rises up to a certain level, and that certain level goes ahead and drains into the drainage system itself. Okay? And then you have, coverings and everything on top of it. So then these are your pipe connections and blow-off condensers and sumps. And it tells you what your vent size is going to be, the boiler blow-off size, the water outlet. Section 810, so we're still talking about steam, hot water drainage condensers and sumps. This section 810.2, it tells you about the tanks, the condensers, and the sumps. They're all constructed of concrete, and they shall have walls and bottoms not less than 4 inches in thickness, and the inside shall be cement plastered, not less than half inch thick. The condensers constructed of metal shall be not less than number 12 U.S. standard gauge, and such metal condensers shall be protected from external corrosion by an approved bituminous coating. So what they're doing is they're telling you, you either go concrete, which is 4 inches thick, or you go with a steel, okay? And that steel has to have an outer coating, and it needs to make sure that it doesn't rust from the outside. The cleaning of the sump, and a sump is the pit, okay? That's what a sump is. Sumps and condensers shall be provided with suitable means of access for cleaning and shall contain a volume of not less than twice the volume of water removed from the boiler or boilers connected to it, where the normal water level of such boiler is reduced not less than 4 inches. So in other words, you need to make sure that you can actually manage the volume of the boilers if they have to dump. Strainers. Indirect waste interceptor is receiving discharge containing particles that would clog the receptor drain shall have a readily removable beehive strainer. So if this indirect waste interceptor is receiving the discharge which contains particles that would clog the receptor, then you got to put a strainer in there. Chemical wastes. Chemical or liquid industrial wastes that are likely to damage or increase maintenance costs on the sanitary sewer system, detrimentally affecting the sewage treatment or contaminant surface or subsurface waters, shall be pre-treated to render them innocuous before discharge into a drainage system. So in other words, you got all this chemical waste and it's going to be detrimental and it's going to start to break down the sewer system. You have to pre-treat it. You have to do something to make sure that does not start to deteriorate or deplete your system through corrosion. Detailed construction documents of the pre-treatment facility shall be required by the authority. Your piping conveying the industrial, chemical, or process waste from their point of origin to the sewer-connected pre-treatment facility shall be of such material and design as to adequately perform its intended function to the satisfaction of the authority. Drainage discharge piping from a pre-treatment facility or interceptor shall be in accordance with standard drainage installation procedures. This one's huge. Copper or copper alloy tube shall not be used for chemical or industrial waste as defined in this section, because copper is reactive to certain chemicals and will actually completely break down. So you cannot use copper on chemical waste. Each waste pipe receiving or intended to receive the discharge of a fixture into which acid or corrosive chemical is placed, and each vent pipe connected thereto shall be constructed of chlorinated polyvinyl chloride, or CPVC, polypropylene, polyvinylidene fluoride, chemical resistant glass, high silicone iron pipe, or lead pipe with a wall thickness of not less than an eighth of an inch thickness, an approved type of ceramic glazed or unglazed vitrified clay, or other approved corrosion resistant materials. CPVC pipe and fittings shall comply with the following standards: polypropylene, those, and blah, 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 blah. So those are all the standards that these things need to adhere to. The most common one nowadays is the CPVC pipe, because they've constructed this chemically resistant piping where you can actually glue it, and there's a specific type of glue that you can use. Whereas the polypropylene, or the PP, you used to have to fuse that with a copper coil, and it was a much more expensive process. Do they still use it today? Yes, absolutely. But the CPVC is the cheapest way to go, and more installations and specifications tell you to do CPVC these days because it's just more readily available. It's cheaper. Joining materials shall be of an approved type. Access. Where practicable, the piping shall be readily accessible and installed with the maximum of clearance from other surfaces. The owner, and again, we're still in section 811, which is the chemical waste section, okay? The permanent record. The owner shall make and keep a permanent record of the location of piping and venting carrying the chemical waste. No chemical vent shall intersect vents for other services. And the reason for that is the corrosiveness of that chemical waste. If the waste has corrosive materials, as acidic or whatever, then as it's being vented and as that air is moving through while the drain is going out, the vent is moving out, it could carry particles of waste through the vent system and actually start to break down and deteriorate your regular normal sanitary systems. So they have to be separate. Discharge. Chemical waste shall be discharged in a manner approved by the authority, which takes you right back to diluting, and that's also section 11.8. The provision of this section about materials and methods of construction shall not apply to installations such as photographic or X-ray darkrooms or research or control labs where minor amounts of adequately diluted chemicals are discharged. That's diluted, right? But if it's so bad, okay, like at the beginning of section 811 where you got to pre-treat it, you know, that's what you got to do. Clear water waste. Water lift, expansion tanks, cooling jackets, sprinkler systems, drip or overflow pans, similar devices that discharge clear wastewater into the building drainage system shall discharge through an indirect waste. Swimming pools, pipes carrying wastewater from swimming or wading pools, including pool drainage and backwash from filters, shall be installed as an indirect waste. Where a pump is used to discharge the pool wastewater to the drainage system, the pump discharge shall be installed as indirect waste. So don't hook it up directly to the sanitary system. Run it over and dump it into a receptor like you're supposed to. Condensate waste and control. Condensate from air washers, air cooling coils. Now we're getting into something that, refrigeration. Okay. Condensate from air washers, air cooling coils, condensing appliances, and the overflow from evaporative coolers and similar water supplied equipment or similar air conditioning equipment shall be collected and discharged to an approved plumbing fixture or disposal area. Where discharged into the drainage system, equipment shall drain using an indirect waste pipe. Okay, that waste pipe, okay, then now we're talking about the indirect waste line going into an indirect waste piping, right? But the waste pipe shall have a slope of not less than 1/8 of an inch per foot. So now we're talking about the condensate being 1/8 of an inch per foot, or 1% slope, and shall be of an approved corrosion-resistant material not smaller than the outlet size in accordance with section 814.3 or 814.4 for air cooling coils or condensing appliances. Condensate or wastewater shall not drain over a public way. What's a public way? Curb, walkway, sidewalk. So let's say you got an appliance up on the roof and you ran it over to the overflow drain or the roof drain. What if that roof drain dumped down onto the sidewalk? Does that mean it's going over a public way? Absolutely. So that is 100% illegal. You cannot dump it into a storm drain. Condensate pumps. Where approved by the authority having jurisdiction, condensate pumps shall be installed in accordance with the manufacturer's installation instructions. Pump discharge shall rise vertically to a point where it is possible to connect to a gravity condensate drain, and then discharge to an approved disposal point. The approved disposal point is going to be an indirect waste receptor. Each condensing unit shall be provided with a separate sump and interlocked with the equipment to prevent the equipment from operating during a failure. Separate pumps shall be permitted to connect to a single gravity indirect waste pipe where equipped with check valves and approved by the authority having jurisdiction. So you can have multiple little pumps that discharge out like a 3/8 tubing, And that 3/8 tubing can hook into a 3/4 condensate drain line, right? You can put little check valves in line to prevent any kind of backup if you have a whole bank of these little 3/8 guys tying into this drain. Condensate control. Where an equipment or appliance is installed in a space where damage is capable of resulting from a condensate overflow, other than the damage to the replaceable lay-in ceiling tile, a drain line shall be provided and shall be drained in accordance with the following sections. An additional protection method for condensate overflow shall be provided in accordance with one of the following. So, this is what we need. A water level detecting device that will shut off the equipment or appliance in the event the primary drain is blocked. So now you have this evaporating coil, and it's condensing, and it's going into a drip pan inside the unit. And then you have a primary drain, and you have an overflow. Or you put in this kill switch. So it's this normally normally closed switch, and as the water level hits it, it opens and shuts off the system. So it trips the system. An additional watertight pan. So number 2 is an additional watertight pan of corrosion-resistant material with a separate drain line installed beneath the cooling coil unit or appliance to catch the overflow condensate due to a clogged primary condensate drain. So now we have this watertight pan that's outside the unit so that if it ever does drip, it drips into the pan. Number 3, an additional drain line at a level that is higher than the primary. That's the most common, is putting in the additional drain line at a level that is higher than the primary drain. Number 4, an additional watertight pan of corrosion-resistant material with a water level detection device installed beneath the cooling coil unit or appliance to catch the overflow condensate due to a clogged primary condensate and to shut off the equipment. So now you have this other one that's pretty much the fail-safe. You've got the pan to catch the water, and then if it hits a certain point and it touches that deal, then boom, it shuts itself off. The additional pan or the additional drain line connection shall be provided with a drain pipe of not less than 3/4 of an inch, discharging at a point that is readily observed. So the key is, this is overflow. It's never really going to see it, or it shouldn't ever see any kind of water. But if it does, it means, holy cow, there's a problem with the primary drain on this air conditioning unit. We need to know. So where are you going to put it? You're going to discharge this thing like right over a doorway or something. So when somebody opens it, it's going to drip on their head, or it's going to drip right on the floor right at the doorway. So you see it, you know what I mean? That's what they talk about discharging at a point that is readily observed. Protection of appurtenances. Where insulation or appurtenances are installed where damage is capable of resulting from a condensate drain pan overfill, such installations shall occur above the rim of the drain pan with supports. Where the supports are in contact with the condensate waste, the supports shall be of an approved corrosion-resistant material. Condensate waste pipe material and sizing. Condensate waste pipes from air cooling coils shall be sized in accordance with the equipment capacity as specified in Table 814.3. The material of the piping shall comply with the pressure and temperature rating of the appliance or equipment and shall be approved for use with the liquid being discharged. So if it's a regular condensate from a regular air conditioning system, chances are you run it in copper, ain't no big deal, you know? So I have the equipment capacity in tons of refrigeration. So up to 20 tons, I'm good with 3/4 inch as far as condensate. Now these are set, these capacities and sizes, they're set based on a certain parameter. I'll go over this real quick, but I'm not going to talk about how to do it. Quite honestly, it's been quite a few years since I've had to do any of this, but I used to do this stuff for a living. So the size of a condensate waste pipe is for one unit or combination of units, or as recommended by the manufacturer. The capacity of the waste pipe assumes 1/8 of an inch per foot or 1% slope. So you're running your capacity and your size based on 1/8 of an inch per foot. With a pipe running 3/4 full at the following pipe conditions. Now this is what I was talking about. And again, I used to do this stuff as a living, the HVAC. That's what I started doing when I first got into the trades. So you take your outside air at 20% and your room air is 80%. You have a dry bulb temperature and a wet bulb temperature. Now, wet bulb temperature is a method of it's calculating the moisture that's in the air and the temperature of the moisture in the air based on the dry bulb, which is just dry temperature. You can take that moisture and you can actually calculate based on these measurements exactly how much condensing material you're going to get, how much condensate, okay, or dew, or you know, the dew point, and how much is going to wick up. Condensate drain size for other slopes or other conditions shall be approved by the authority having jurisdiction. Air conditioning waste pipe shall be constructed of material specified in Chapter 7. Cleanouts. Condensate drain lines shall be configured or approved or provided with a cleanout to permit the clearing of the blockage and for maintenance without requiring the drain line to be cut. Appliance condensate drains. Condensate drain lines from individual condensing appliances shall be sized as required by the manufacturer's instructions. Condensate drain lines serving more than one appliance shall be approved by the authority. Point of discharge. Air conditioning condensate waste pipes shall connect indirectly, except where permitted in section 814.6, which is down below, to the drainage system through an air gap or air break to a trapped and vented receptor, dry well, leach pit, or the tailpiece of a plumbing fixture. A condensate drain shall be trapped in accordance with the appliance manufacturer's instructions or as approved. Now, the last one there, that last sentence about the condensate drain having to be trapped in accordance with the appliance manufacturer's instructions, because the trap depth sometimes has to be a deeper seal or a lower seal based on your static pressure. Is if it's a positive pressure or a negative pressure, if the condensate drain discharge is on the inlet side of the airflow or the outlet side of the airflow from the coil itself, because it gives you different pressures. Okay, so based on pressures, you're going to have a deeper, because obviously if it's a bigger pressure or a larger static pressure in this condensing unit, then a larger static pressure is going to require a deeper trap. Condensate waste from air conditioning coils. Where the condensate waste from air conditioning coil discharges by direct connection to a lavatory tailpiece or to an approved accessible inlet on a bathtub overflow, the connection shall be located in the area controlled by the same person controlling the air-conditioned space. So you can't have your neighbor in an apartment complex running his condensate into your lavatory. And then plastic fittings. Female plastic screwed fittings shall be used with male plastic fittings and plastic threads. The reason for that is if you were to hook a female plastic screwed fitting into a male copper fitting, the male copper fitting is not going to bend, okay? It's pretty rigid. However, as you tighten in a female plastic screwed fitting into copper, that plastic wants to expand, especially if it gets cold and warms up, it's going to want to expand. And that stuff is pretty brittle and it will actually crack. So female plastic fittings go to male plastic fittings. They both have a certain amount of give to them and they're not as expansive as a copper is. So guess what? Indirect waste chapter is done. The next chapter, which is chapter 9, is pretty much just as short, but we'll probably spend a little more time on it because it's chock full of information. As was this chapter. I'm not going to lie. This chapter was just as informative. So I'll see you on the next chapter. And again, that will be chapter 9, venting.